Now we are going to solve another problem using Kuhn condition with one constraint. So the objective function is maximization of z is equal to 3x1 square plus 4x1 x2 minus 8x2 square subject to 3x1 plus 6x2 less than or equal to 72, but subject to x1 and x2 greater than or equal to 0. Now we shall solve for the four conditions. First one, lambda I is greater than or equal to 0. Since we have only one constraint, we take lambda 1 is greater than or equal to 0. The second condition is L is equal to f of x minus lambda I g of x. So L is equal to f of x is the objective function and g of x is the number of constraints we have. Since we have only one constraint, we will multiply only with lambda 1. So 3x1 square plus 14x1 x2 minus 8x2 square minus lambda 1 into 3x1 plus 6x2 minus 72. Now we'll differentiate lambda partially with respect to x1, x2 and lambda 1. So dou L by dou x1 is equal to 6x1 plus 14x2 minus 3 lambda 1 is equal to 0. We take this as the first equation, and dou L by dou x2 is equal to 14x1 minus 16x2 minus 6 lambda 1 is equal to 0, and we take this as the second equation. Dou L by dou lambda 1 is equal to minus of 3x1 plus 6x2 minus 72 is equal to 0, and we take this as the third equation. The third condition is lambda I gi of x is equal to 0. Since we have only one constraint, lambda 1 into 3x1 plus 6x2 minus 72 is equal to 0. And the fourth condition is gi of x less than or equal to 0. That is a single constraint we have, 3x1 plus 6x2 minus 72 less than or equal to 0. We take this as the fourth equation. Now we will solve two cases providing lambda 1 is equal to 0 and then lambda 1 is not equal to 0. So case 1 is lambda 1 equal to 0. So we take the first equation and we substitute lambda 1 is equal to 0. We get 6x1 plus 14x2 is equal to 0. And the third equation multiplied by 2, we get 6x1 plus 12x2 is equal to 144. While solving this, we get x2's value as minus 72 and x1 as 168. Since x2's value becomes negative, it is infeasible solution. Now we shall solve for having lambda 1's value not equal to 0. Case 2, we take lambda 1 not equal to 0. The first equation becomes lambda 1 is equal to 6x1 plus 14x2 divided by 3. Equation 2 becomes lambda 1 is equal to 14x1 minus 16x2 divided by 6. Since we have lambda in both the equations, I'll take lambda to one side so that I may equate x1 and x2 and form an equation to again solve with the third equation to get x1, x2 value, and then I can find out the lambda value. So now I can equate equation 1 and 2, the minimized equation of 1 and 2, such that the left hand side value is same so that I can equate the right hand sides. So equating RHS, 6x1 plus 14x2 by 3 give is equal to 14x1 minus 16x2 divided by 6. Since 3 and 6 are multiples, I cancel out 1 and 2. So I get 12x1 plus 28x2 equal to 14x1 minus 16x2. On solving this, I will get 2x1 plus 44x2 equal to 0. I shall take this as the fifth equation. Now I shall solve the fourth equation and the fifth equation. So I multiply the fourth equation with 2. So I get 6x1 plus 12x2 equal to 144. Multiplying the fifth equation with 3, I get minus 6x1 plus 132x2 equal to 0. On solving these two equations, I get x2 as 1 and x1 as 22. To check whether this abides with the constraint given, I shall substitute x1 and x2 value in this. So 3 into x1 plus 6 into x2. 3 into x1 plus 6 into x2 gives 66 plus 6, which gives 72. So it is, the constraint is less than or equal to 72, and I have got 72, which is less than or equal to 72. So it abides the constraint. So x1 and x2 values are acceptable. Now I shall substitute this in the objective function. So z is equal to 3 into 22 square plus 14 into 22 into 1 minus 8 into 1 the whole square. So I get the z value as 1752. In case 1, we have got an infeasible solution since x2's value becomes negative. So the case 2 is the most probable solution. The value of x1 is 22 and x2 is 1. The value of z is 1752. And we shall solve it for lambda 1. So to find lambda 1, I can take any one of the solution as 1 or any one of the equations 1 or 2. So I take first equation, 6 into x1 is 22, 132 plus 14 equal to 3 lambda 1. So lambda 1's value is 146 by 3. So we get lambda 1 as 48.66. So this is the final answer, where lambda 1 is equal to 22, x1 is equal to 22, x2 is equal to 1, lambda 1 is equal to 48.66, and the objective solution, that is the main function maximization of z, is equal to 1752.